In this video, I am going to do problems from Chapter 4, the Together Problems of 43, as well as 52, and I'm going to talk you through the beginning of 51 so that you can then practice the skills that hopefully I'll explain to you, and hopefully be really good at determining concentration of ions. Now, 43 we've already talked about. But I'm going to talk you through again. And if you read 43, if you don't have your book out, you probably want to get a copy of the chapter 4 problems out. First one says 43, and it wants to know how many grams of sodium chloride can be produced or prepared by the reaction of 100 milliliters of 0.20 molar silver nitrate as well as 100 milliliters of 0.15 molar calcium chloride. Okay, so those are the two reactions, the two solutions that we are combining. Now, I'm going to come back to the math here in just a second, but I'm going to talk you through molecular and net ionic, molecular and net ionic equation for just a second, because you're going to need both of them in this reaction. Okay, your molecular, first of all, and we'll come back to the work on this slide here in just a second, is silver nitrate plus calcium chloride gives us calcium nitrate and silver chloride. This is a very straightforward precipitation reaction. This is the solid, and the spectator ions here would be nitrate and would be calcium. Okay, so you're going to see the net ionic here in just a minute is going to be, or would be, silver plus the silver ion with a 1 plus charge plus 2 chloride ions. Actually, we end up kind of gets a little funky here because you've got 2 silvers plus 2 chlorides gives us 2 silver chlorides, which is going to reduce down to 1 of each. But this particular problem, you need to have a working knowledge of both the molecular and the net ionic because it's asking you for grams of silver chloride at the end. So for those of you who use the chart, you can still set it up this way, but for those of you that don't, you still need a working knowledge of both the molecular and the net ionic to get the right answer. Okay, now before we get to which one we need when, let's first talk about moles, because remember, whenever we're dealing with solutions, the big trick in order to get to moles is to use molarity. So over here, I've already done this. For the silver nitrate, I've taken 0.20 which is our molarity, multiplied it by 100, 0.100 liters or 100 mils, and figured out that there's 2 moles of, 0.02 moles of silver nitrate. And since it's a 1-to-1, there's also 0.020 moles of just the silver ion itself. So since it's a 1-to-1, we have 0.02 moles of silver nitrate and the silver ion. Now for calcium chloride, I've showed you in 2 steps. The calcium chloride, you still take the molarity, which is 0.15, you multiply it by the volume. So remember, the big trick with molarity, which hopefully we're good at now, take the molarity, you multiply it by the volume or the liters, and you can get moles, okay, because they cancel out just like that. So for our moles, I'm going to give you 2 amounts here. We've got 0.015 moles of calcium chloride, which you're going to see I plugged into my chart, but also thinking ahead, remember when we deal with ions, we have to take into account subscripts. And for each mole of calcium chloride, you have 2 moles of chloride ion itself. So in reality, you have 0.030 moles of chloride. And we're going to need both of these numbers to start with. And again, for those of you who are doing dimensional analysis, I know you're pretty good at going from moles of something to moles of something else with a balanced chemical reaction. I'm just going to show it in the chart. Honestly, there are times where I like using the chart because it just allows me to keep all of the information about an equation in one place, but both ways will get you the right answer. Okay, so the first question wants to know how many grams of silver chloride. So I just took the moles of the compounds, all right, the 0.02 moles, I know I keep flipping back and forth here, but just to show you the 0.020 moles of silver nitrate and the 0.015 moles of calcium chloride, because when I'm dealing with grams of precipitate, I have to keep those in mind. And I plugged them into the chart. Okay, I divided by the molar mass, or the mole ratio rather, and found that the limiting reactant is my silver nitrate. Okay, that's my limiting reactant right there. So that's what I brought across. The molar mass of silver chloride is 143.4, which gets me a final answer of 2.9 grams. And I think most people are pretty good with that skill at this point. If I'm given amounts, even if it's in a solution, figuring out grams of product, that's good. Where we get tripped up is the next part, and that's going to be finding the concentration. Remember, these little brackets right here are our abbreviation for concentration. And whenever we're looking for concentration of ions, we're looking for the moles per liter, and it's in molarity. And there's 4 ions that we're dealing with in this solution. You have silver ion, the chloride, the calcium, and the nitrate. Now, just as a reminder, whenever we combine 2 solutions, whenever you find the final molarity, you divide by the new total volume. And for this reaction, we took 100 milliliters of each solution, we added it together, so the total volume, whenever we're going to find these molarities, is going to be 0.200 liters. Now, if you think back here for just a second, we already identified silver as our limiting reactant. So since silver ion is our limiting reactant, it's the easy one, really easy, because guess what? It's 0. If we used it all up, there should be none left. So it is the easy one, meaning that it's going to be 0. Now the one that is tougher, which we don't like as much, right, is going to be chloride. Now I'm going to come back to that one here in just a second. I'm going to start with the spectators, because remember, spectators are ions that don't participate in the chemistry. So if you go right back to that very beginning when we found the moles of each compound, there were no curveballs, because when we found the moles of each compound, there's 1 mole of silver nitrate, 1 mole of nitrate and silver nitrate, 1 mole of calcium in calcium chloride. So I can use 0.020 and 0.015 to go ahead and calculate the concentrations at the end, because they don't participate. So calcium, remember, is going to be 0.015 divided by 0.200 liters. And let me see here. So calcium is going to be 0.015 divided by 0.2. Oops, that's not it. 0.015 divided by 0.2 is going to be 0.075 molar for molarity. And nitrate is going to be 0.015, because it'd be 0.020. 0.020 divided by 0.200. 0.10 molar. Okay, 2 significant figures in both of those answers. So there are my answers for the calcium as well as the nitrate. All right, now I'm going to go to the chloride. And the chloride's a little bit of a tough one. And if you're still struggling on how to figure out how many moles are left over, you may want to go back to the chart, honestly, at this point. Some of you are good at it. I don't know what that means, so show me that message again. Some of you are really good at it, and that's fine. But for those of you that are still really struggling, remember, you have to figure out the moles of each ion. And right here, this is the curveball on this question, is that at the very beginning, we remembered, or we discovered, that in every mole of calcium chloride, there are 2 moles of chloride. So our amount of chloride is twice as much calcium. So it was 0.030. So here is what I had available. So remember, if we think about it, I know it's a 1-to-1 and that makes life easy. But whenever we did excess with the chart last year, we had to bring this one over, bring it back up the chart, and this is what you subtracted. Okay, or you could have just known, pick a different color here, you could have known that you had 0.030 volt available and that you used, there's about 4 or 5 different ways to do this, but either way, you should end up with 0.010 moles left. And that's what we use to determine concentration. So we come over here, we have 0.010 divided by 0.200, because remember, that's still our new total volume. So for the chloride ions here, we're going to end up with a final concentration of 0.050 molar. Now I did a really bad job here, because whenever we put molar, we also want to put what we're talking about. So this one should have been 0 molar silver ion. This is 0.050 molar chloride ion. You've got 0.075 molar calcium ion, 0.010 nitrate ion. Okay, so that is 43 again, just to explain it. Now let's talk 52. 52 I kind of wrote out to get us started here, so you wouldn't have to waste time watching me write it out. What 52 is asking you is how you take hydrochloric acid and you have 75 milliliters of a 0.250 molar. So there's my hydrochloric acid data right here. You're going to combine that with 225 milliliters of 0.0550 barium hydroxide. And what it wants you to know, or wants you to solve for at the end, is what is the concentration of excess hydroxide, excess either hydroxide or hydrogen ion. Doesn't want to know all of them, it just wants to know the tough one, okay? So here is the molecular version. However, we don't need necessarily a working knowledge of the molecular version because it's never asking me to find grams of a precipitate. This is not a precipitation reaction. This is an acid-base reaction where hydrochloric is your acid, barium hydroxide is your base, you're making water and a soluble salt. So the net ionic here, because this is a strong acid and a strong base, chlorine can precipitate out, and barium chloride is aqueous, so chloride is going to be a spectator. Barium is going to be a spectator. So my net ionic equation here is hydrogen plus hydroxide gives me water, which makes the math very easy because once I figure out the moles of them, I can do everything else pretty quickly. But again, there is one major curveball here in that barium hydroxide has 2 moles of hydroxide. So let's see what this looks like. So here is the molarity math. So you've got 0.250 molar, you've got 75 mils, which gets you to 0.0188 moles of hydrochloric. Remember, there's 1 mole of hydrogen for every 1 mole of hydrochloric, which lets me know that at the end I only have 0.0188 moles of hydrogen ion. Now over here on this side, for my barium hydroxide, I take the molarity, I multiply it by the volume to get 0.0124 moles of barium hydroxide, but I'm not done because there are 2 moles of hydroxide for every, whoops, that should say on the bottom. Let's try this, fix this here. This should say for every 1 mole of barium hydroxide. So therefore, available, I have 0.0248 moles of hydroxide. Okay, so remember, this is the curveball right here, is that there's 2 moles of hydroxide for every 1 mole of barium hydroxide. So now if I come down to, well, I don't want any of that response stuff. If I come down here, I've just made a little summary chart again. Hydrogen is my limiter. Well, because it's a 1-to-1. I don't have to do any funky math. I could bring it all the way down here and do change and find out, but this is my limiting reactant. So I know now I'm looking for what is the concentration of excess hydroxide. All right, well, how do I do that? Remember, the 0.0248 is what I had available. This is what was available at the beginning, but I know that there is excess. So if you're still struggling, I do just like we did last year. I take the limiter, I bring it over here. This is the one where we had 2 columns, 0.0188. The change is 1, so it's still 0.0188. And I subtract those 2 numbers. Okay, so when I take 0.0248 and I subtract 0.0188, what I end up with 0.0248 minus 0.0188, going to be around, 0.006. All right, so what I end up with when I subtract them, I know I'm not really worried about the water here, but it's 0.006 moles of excess. Now remember, I'm not quite done. It wants to know concentration, so I have to take those 0.006 moles and divide it by the volume. Now you'll notice if when you read the question, it says, nope, it just says ions left in solution. So all I have to do now is divide it by the new total volume, which was going to be 75 mils plus 225, which is 300, so that's going to be 0.300 molar. We take those, and we end up with 0.006 divided by 0.0060. That would have been 2 sig figs for the subtraction, 2 sig figs here, but it would be molar of hydroxide, and that is my final answer. Okay, now really quick, so I'm going to run out of time. 51 is almost the exact same type of problem. You just added grams of sodium hydroxide I wanted to know if it was acidic, basic, or neutral. You remember your final concentrations are going to be moles per liter. The easy ones are the nitrate and the sodium because they're spectators. One of these is going to be tricky because it's excess. One of them is going to not because it's the limiter. The only thing you got to do is get both of them to moles, and then you can solve for the reaction. Okay, so hopefully you can try 51 with better confidence. If you need more help, let me know, and we'll get